Elastic agencies. Okay, so let's start our lesson today. Nicholas, before we continue, I just need to remind you, do you check the Taylor's email? I think you need to fill up a form, right, for your AX examination. So please check your email. You have to check your email. There is an AS application. I think for the exams, you have to fill in the, I think what paper you're going to sit. Okay, those who haven't checked, go and check the Taylor's email. Okay, so that is an important document for you to check prior to sit for the AS examination for registration.
So physics is 3 papers, correct?
Yeah, physics is the 3 papers. The AS part, the AS part.
Okay.
Towards the end, the last column, I think. AS, paper 30, paper 3, paper 1, paper 2, paper 3. 12 or 13, I don't know. 1, 3 or 1, 2. The code, because paper 1 normally have 1, 1, 1, 2, 1, 3.
I think it's 1, 3.
1, 3, yeah. So till I think Malaysia, this region chooses 1, 3, so 1, 3, yeah. Last column. Any other questions, guys, before we start today's lesson? No questions, Okay, so let's see, recall back what we did last class, Okay, so motion in a circle again,
Yeah.
Okay, so let's do a recap what we learned about this last class. So we learned about what is angular displacement. We talk about angular velocity, omega, theta over t, 2 pi over t, 2 pi f, radian per second. Then we talk about a linear velocity, how linked to omega, v equals to r omega. Then we talk about, omega is 2 pi over t, 2 pi f. Then we talk about anything move in a circular path with a constant speed, it do accelerate. The acceleration is towards the center of the circle. That acceleration given a special name, centripetal acceleration. Okay. So the centripetal acceleration formula is v squared over r, or r omega squared. And yeah, so this is the differences, linear and angular. The displacement, linear displacement is analog to theta, like angular displacement in angular world. So v here, linear velocity, here is like omega. V is rate of changes of displacement, omega is rate of changes of angular displacement. Okay, acceleration is the same. Acceleration is the two formulas. The middle one not that famous. First and the last is important. Yeah. Then we talk about centripetal force. Okay, anything move accelerates, that means act upon by an unbalanced force. So that force we label it as centripetal force. Also act the same direction as the centripetal acceleration towards the center. And the centripetal force is mr omega squared, mv squared over r. You can put mv omega, also not that famous. These two are more famous, the second and third. Okay, so that day we did the horizontal circular path. We discussed what are the forces acting, and we come out what equals to centripetal force. In this case, we found that the tension is the centripetal force, and we did some one question, like your friend like holding and whirling it horizontally. So what is the V max it should have? So we discussed that. Okay, now we're going to continue from there. We go to the Word file again. Okay, so we go to the example. Yeah, so that day we did this example. Okay, remember, now we're going to go for the next example of circular motion. Okay, this is the one. Okay, this is the one of the complex circular motion. If you able to understand this example, I think the remaining all going to be easy. Okay, not that difficult. If you could understand this. Okay, before we referring to this, this is a ball on the end of a string, same like the first case, but we now whirl it, rotated it vertically. So vertical circular motion. Okay, your friend is standing and whirling it vertically. Okay, up and down. Okay, so above, against the gravity, go up, come down, go up, come down. So how the centripetal force going to react now on this system? Okay. Before we referring to this equations in all over the place, let's we build one. Okay. So now vertical, vertical circular motion. So let's say you whirl the pendulum vertically. Okay, center. These are the three critical position we're going to discuss. This is A, this is B, this is C. Okay, what we're going to do, you want to find at A, at B, at C, you want to find what equals to the centripetal force for that system. So this is what we're going to do. What equals the centripetal force of this system? Okay, so remember in exam, any circular motion question arises, first thing you have to do is you have to analyze the system. How do you analyze the system? Identify all the forces acting. Draw the free body diagram. Okay, let's go for the A. At A, what are the force acting on this system? A string tied to a pendulum, which a mass which is whirled vertically. What are the force acting on A? What force acting down? Of course, the weight acting down, mg. What force acting up? Any force acting up? The tension, right? The tension acting up, correct? The tension is acting up. So any other force acting here? We ignore the air resistance. We ignore the air resistance. So these are the two forces acting, right? Okay, go to the B. What are the forces acting in which direction? B, the weight acting down, always down. C, also the weight acting down, mg down. How about tension at B? Towards the center, right? Tension is always towards the center, against the object. At the top, where's the tension acting? At the top. The tension will be acting downwards, right? Because it moves up, so the string will be tight, so the tension will act downwards, referring to the object. Okay, so those who got in your mind, this is the set, these are the forces acting, so you're good. Any questions about free body diagram? Okay, guys, now get me at point A, what equals to centripetal force? Remember what I told you last class. Whatever force acting towards the center minus whatever force opposing it is the centripetal force. Okay, so at A, what going to be the centripetal force? Reynolds, yeah, Reynolds.
Yes.
Any idea? What do you think? at
Is
A?
it tension minus like the weight?
Very good. Tension minus mg. So whatever force acting toward the center, tension minus the mg is acting opposing it. So tension minus mg is mv square over r. Okay. B. So what do you think? B. B, whatever force acting toward the center minus whatever force opposing it. What force acting toward the center? Tension. Okay. Any force opposing it? Is it mg opposing the force or helping the force? Because mg acting 90 degrees to both sides, if you resolve, it becomes 0. So it's never help, never oppose. Anything 90 degrees to the direction towards the center doesn't support or oppose the centripetal force. So B, the equation is tension equals to mb square over r. Okay. C, what equals to centripetal force at C? Pranav here? Pranav? Pranav, can you hear me? Oh, silent, Okay. So check what are the force acting down. What are the force acting down? The weight acting down, the tension acting down. So both acting toward the center. So what equation should be? Tension plus mg is the centripetal force. Okay, so these are the three equations equals to the centripetal force for this system. Okay, every point a different type of arrangement. Okay, so now we're going to investigate based on this. Okay, what is the use of this formula for us to investigate this? Okay. So first, anybody got any doubt about this equation? Any part you don't understand about the equation? Please stay with my idea. Whatever force acting toward the center minus whatever force opposing is your centripetal force. Okay. Okay, now let's investigate this. Okay. Look at these three equations and imagine like you are like holding a, it's very difficult to show. You must experience that. Maybe you can try this later. Okay. Okay, let's say, imagine your friend holding a string as usual. So the radius is 0.5 meter. The mass is 1 kilogram of mass tied at the end. Now he tend to whirl it up and down, okay, vertically. And let's say the string he used as a maximum tension of 500 Newton. Okay, the string as a maximum tension of 500 Newton. You whirl it up and down, vertically up and down. Okay. So now, okay, just for the easy to calculate, I take instead of mass 1 kilogram, I just put here the weight. The weight of the mass, let's say, is 10 Newton. I take the weight as 10 Newton. Weight as 10 Newton. Okay. Now let's say your friend whirl it vertically up and down with the speed of, let's say, a certain speed, until its centripetal force. When we calculated the centripetal force mv squared over r, let's say is 450 Newton, let's say. Okay. So you whirl the system vertically such as the centripetal force reached 450 Newton and the weight of the object is 10 Newton and the maximum tension of the string it possesses is 500 Newton. That's the maximum tension. Okay, now tell me, investigate this system now. When you roll it vertically up and down, what is the tension in the string at position A, B, and C? Use the labeling I shown here. A is the bottom, B is the side, C is the top. So based on this equation, and the FC circle it 450 and weight is 10 Newton. What is the tension at the bottom will be at A? At the bottom, at A, the tension will be how much? At A, tension will be how much? How much the tension at A? So what do we do? This is the equation, right? The 8th equation. So tension at A is found to be mv squared over r. Mg bring the other side is plus mg. So in this case, tension at the bottom is how much? Centripetal force, you hold it at 450 and weight is 10 Newton. So tension at A will become like 460 Newton. Okay. So when you whirl it with that particular speed, which for the centripetal force of 450, the tension at the bottom will be 460 Newton. You will experience tension 460 Newton, string. How about at B? At B, the tension is, if you referring to the equation above, okay, if referring to the equation above, so tension is for B is exactly same as the centripetal force mv squared over r. So tension at B will be how much? Exactly same as the centripetal force. It's going to be tension at B will be 450 Newton. So how about tension at C? So tension at C is, you use this equation above for the C. So it's actually mv squared over r. Bring the mg the other side is minus mg. So the tension at C is found to be 450 minus 10, so it becomes 440 Newton. Please look at the values, the tension at every point. Okay, when an object whirled vertically up and down, the tension on the string, is it constant? It's not constant. The tension of the string is varying in all directions. Which position tension become maximum? Which position the tension become maximum? At the bottom or at the top? A, B, C, where? At A, right? The tension is 460 Newton. At the top, the tension becomes 440 Newton. So from here, what you can understand, the tension become maximum at which point? When the tension become maximum, at which point? At the bottom, which is the A. So remember, when your friend whirl it up and down, the tension of the string varying, and the tension of the string become maximum at the bottom. How you know the tension is maximum? From this derivation, from these formulas. And the tension become minimum at the top. Okay, so that's the first investigation. Okay. So now we're going to advise him again. Okay. So now your friend is holding a a string with Tmax 500 Newton, radius of 0.5 meter, and he hang a weight of 10 Newton. He want your advice. He want to ask you what speed to whirl it. What speed you need to whirl? Can we whirl? Can he whirl it with any speed he like? Or he has a certain limit? Do it as if it has a certain limit, do it as a maximum limit or a minimum limit, or both? Okay, so you need to advise him. Your friend is holding. So what do you think? Do you have a maximum limit, minimum limit, or both? If it has a maximum limit, means what? It cannot exceed that value. If the speed exceeds that value, that means something would happen to the system. Okay. So do the system has a maximum limit? Ashley, what do you think? It has a maximum limit?
Yes.
It has a maximum limit. So you feel that there is a Vmax. Huh? Why you say there should have a Vmax? If it exceeds, what will happen?
Will the string break?
Okay, good. The string will break. Most likely the string will break at which point? Ashley?
When the tension is greater than centripetal force.
Okay, so let's say your friend is whirling it vertically up and down. He slowly rises the speed until it exceeds the Vmax. For the first time, where it most likely to break? At the top, at the bottom, at the side? Yeah. Genuine? Yeah? Genuine?
So I can repeat the question again.
Okay, your friend is rolling it so vertically. So I'm asking, do the system? We need to give him a limit. Don't go beyond this speed. Don't go less than whatever. So according to Ashley, she said there is a Vmax. That means there is a certain maximum limit. That means he can't go beyond that. So we agree to that because the system should have a certain maximum speed. If you go beyond that, the string going to snap. Okay. Now my question is, which point is most likely to snap? Which point move by the time you're rolling it? Which point most likely going to snap? At the bottom or at the top?
Thing at the top.
At the top. Very good. So at the top, it most likely to snap. Why? Only at the top we found that the tension become maximum. Okay. So yes, good. The first thing is Vmax. There is Vmax. So Vmax, we want to find the V maximum. Okay. So now, so can you help him? What is the Vmax for this above system? You want to find Vmax. What is the Vmax of above system? So first you must send. We must discover. First you consider which point. Consider the top or bottom. So which point is the critical point to measure the Vmax? Where it most likely to break? It most likely to break at the bottom. So to find the Vmax, consider the bottom. So you consider the bottom point. That's the most critical point. Consider the bottom, which is in this case is the A. Okay. So we get the equation for the A. At A, what is the equation for tension? Tension at A is what? From the top, tension acting arc. So tension minus mg equals to mv squared over r. Okay, so this is the equation. Okay. Okay, this is all you need to write, but I give a time later. First, try to look at the working first before I allow you to write. Okay, we want to find Vmax. So Vmax, we consider the bottom. Why we consider the bottom? Because the tension become maximum at the bottom. Okay, so yeah, now give a statement. When V is maximum, then tension will achieve Tmax. Tension will achieve the maximum tension value. When V is maximum, the T become Tmax. Okay, a statement. So now above equation, Tmax minus mg should be equals to mv max, max squared over r. So when V is max, T achieve its maximum value. Okay, T achieve its maximum value. So make the V as a subject. So V max is what? So rearrange back. So equals to T minus mg r over m square root T max. Okay. So this is the formula to get P max. Okay. So now moving up. So for this system, let's calculate. Okay. So for this, your friend, the Vmax of the system should be root of tension. How much? The tension, string tension you use, the maximum tension is 500 Newton. The weight is 10 Newton. Okay. And the radius was 0.5 meter. If the weight is 10 Newton, what is the mass will be? Mass will be 10 divided by the 9.81 gravity. So to get the mass, we put the mass, then you get the answer. This is the Vmax. Okay, please, someone please calculate for me. How much do you get for this? .01.
15.5.
Yeah, how much you got?
15.5.
15.5. So let's say we go 15.5 meter per second. Okay, yeah. Okay, good. So just make it small. Okay, so your friend which is trying to roll it vertically, so now you can advise him. Okay, so don't go beyond 15.5 meter per second. Okay, so according to his system, if he whirl it more than 15.5 meter per second, most likely going to snap at the bottom. It's going to snap at the bottom. Okay, the string. So there's the limit 15.5. In exam, they will ask you find the Vmax. So you should know, consider the critical point. The most critical point where it most likely to snap is at the bottom. Okay, that's the important thing you have to know by today. It's at the bottom. Why we say bottom? Because see, based on equation, the tension is maximum at the bottom. For the entire points, the tension is maximum at the bottom, according to the equation. You see 460, 450, 440. So the bottom always reach the max. So we consider the bottom, write the equation, centripetal force for the point at bottom. When V is max, tension is max. You need to aware that. When V increasing, the tension will increasing for the string. But when V is max, tension will achieve the maximum value. Then we find the V max. 15.
Sir, shouldn't the top be the critical point?
Okay. There are actually 2 points. That's top for another type of speed. That is V minimum. Do you agree? V minimum, we consider the top. That's the next question. Okay. Okay, one of your friends said it should be top. Okay. So yeah, we're going to discuss about the top now. But for V max, should be the bottom. For V max, bottom, because tension become maximum at the bottom. Okay, now because your friend said it should be top. Okay, let's see. Top also involved. Okay, top. You need to, now your friend listened to your advice, or you said, okay, good. So V max is 15.5. So you think in your mind, in his mind that, or you can roll it at any speed you like, less than 15.5 will do. Okay, let's say you roll it like 1 meter per second, 0.5 meter per second, also will do. It will succeed rotating it vertically. But in reality, no, right? He has a V max, of course, he can't exceed that speed. But do you agree they should have a V minimum also? It should have a certain V minimum too, right? Just now, who asked the question? Daniel.
Yeah, no, but me, Zgen. Yeah.
Zigen. Okay, Zigen?
Yeah, it should have
okay.
minimum.
It should have minimum, all right? It should have a certain minimum limit also, right? Because if he never reach that minimum speed, what will happen to that circular motion? Zigen?
It won't spin.
Yeah, he can't complete one circle, right? He can't complete one circle. Okay, so now not enough for this person to tell about Vmax, but this system for the first time it has another speed called V minimum. It has a V minimum. It has a V minimum. V minimum exists for this system. Okay, that means if we go lower than this V minimum, what will happen? The pendulum will go up, but halfway it will drop down. It can't reach the top. It couldn't reach the top. Okay, to reach the top, you need to swing it with a certain minimum speed. You can't go less than that. Okay. Okay, now let's investigate what is the V minimum required for this system. Okay, as usual, we follow the same idea of the above. V max, we consider the bottom. V minimum, we consider which point to find V minimum? Anybody? Jantat?
Yeah,
To investigate V minimum, we consider which point?
the top point.
Yeah, very good. Consider the top. You consider the top because top is now the critical point for V minimum. If you go lower speed, the most critical point it difficult for it to achieve is the top. Okay, if it able to achieve the top, then that's where the V minimum achievable. So consider the top. That means point C. Okay, the top. Like the string is at the top. When the pendulum is positioned at the top, what equals to centripetal force at the top? What is the centripetal force at the top? What force acting at the top? The mg acting down. The the tension also acting downwards. So T plus mg is equals to mv squared over r, and consider the top. Okay. So now we're going to give a statement. When V is minimum, what becomes 0 Newton? When V is minimum, when you go to the top, when you roll it on the top, when you go to the first case, you go up here for the first case, you see, temporarily. You see, you whirled here with a centripetal force of 450 Newton, 450 Newton at the top, which is the C, the top, the tension is 440. Okay, 440. The tension is 440. That means the string is really tight, so the tension act downwards. Okay, so if the centripetal force, he reduces the centripetal force to 10 Newton, let's say. He reduced the centripetal force here to 10 Newton. Okay, here 450. Now I cut this 450. He whirl it so that centripetal force is 10 Newton. Okay, centripetal force now is 10 Newton. What is the values here for these three tension will be? At A, at the bottom, what is the tension will be? FC is 10 Newton. At the bottom will be mv squared r plus mg, So 10 plus 10, so FC is 450 plus 10, now it's 10 plus 10, right? So it's going to be 20 Newton. At the bottom, the tension will be 20 Newton. At the side, the tension will be exactly same as the centripetal force. In this case, centripetal force is 10 Newton. So the side will be 10 Newton. At the top C, what is the tension will be? Anybody? At the top, tension is what? Centripetal force minus mg. Centripetal force is 10 Newton. Weight also 10 Newton. So 10 minus 10 is 0 Newton. This is a very critical point. You see, you whirl it with a centripetal force of 10 Newton. The tension at the top become 0 Newton. Okay. When the tension is 0 Newton, what is the meaning of that? Is it moving in a circular path? Yes. At the top, the pendulum just floating without any tension. The tension is 0 Newton. There is no tension. So the weight, the mass will experience a situation called, I don't know whether you recall this or not, weightlessness. Have you heard of weightlessness? So weightlessness. So weightless means like a floating effect, where the tension is becomes 0. So when the tension is 0 Newton, he still make the circular motion. He able to reach the top. Still able to reach the top. But that is the limit. The tension, the limit lowest can go at the top when it move around. The lowest it can go is 0 Newton. Okay, 0 Newton. Okay. Now, if your friend, which is as a wallet with the centripetal force 10 Newton, you make it 9 Newton. Is how to make it 9 Newton? That means you slow down further. You make it 9 Newton. What will happen to the tension at the top? When the centripetal force is 10 Newton. Now it become 9 Newton. What is the tension at the top will be? 9 minus 10 will become what? Negative 1 Newton, right? The centripetal force 9 Newton, 9 minus 10 will be negative 1 Newton. Do you have tension such as negative 1 Newton? That this indirectly tells what? If tension is negative value, that means indirectly tells that the object doesn't reach there. It can't reach there. No way it can reach the top. Okay. So the lowest value the object can reach the top is with tension 0 Newton. Okay, remember why I'm talking about this. Tension must be 0 Newton because we want to use the minimum speed. Okay, we go up here. Okay, so now V minimum. So when V is minimum, what should become 0? What should become to the lowest? When centripetal force changes, what changes? Is it weight changes? Weight never change. What going to change accordingly? The tension going to change accordingly, right? When centripetal force goes down, the centripetal force goes down, the tension will goes down. But the lowest tension can go is to stay the circular path. The lowest it can go is 0 Newton. Okay, when that happen, when V is minimum. When V is minimum, tension must be 0 Newton. Very important statement. Okay, guys, hope you understand this point? Any part you don't understand for V minimum? So V minimum needed. You need to tell V minimum to your friend. If not, you're not going to complete the full circular motion. It most probably going to drop halfway. So to calculate the V minimum, we consider the critical point. The critical point should be the top point, top C. So at the top, the centripetal force is T plus mg. T acting down, mg acting down, so T plus mg equals to centripetal force. So when V is minimum, T go to this smallest value, 0 Newton. Okay, now you can find the V minimum. So therefore, from the equation above, mg should be equals to mv squared over r. V is the V minimum. Tension is 0, so it's 0. No tension. When V is minimum, tension is 0. So the V, when you rearrange, you will get this equation, root of Rg. Okay. So the V minimum for this system is root of Rg. I can say this is one of the famous derivation they will ask in circular motion. Okay. Show that the V minimum for a vertical circular motion is root of Rg, like a 3 marks question. Okay, so this is the derivation you have to show. Maybe the first mark they'll give the equation 1 mark, the statement like 1 mark, and the final 1 mark. Okay, V minimum. Okay, so now your friend just now we told him V max is 15.5 meter per second. Don't go beyond that. You're going to snap at the bottom. Now we help him to find the V minimum. V minimum for his case, how much V minimum? Anybody? V minimum? V minimum will be what? V minimum is calculate root of Rg. So in this case, is root of R is how much? What is the radius of the circle he makes? 0.5 meter. And the gravity we take 9.81 square root. So what speed is this? How many meter per second? Somebody can help me to get 9.81.
2.2.
2.2. Okay, good. 2.2 meter per second. This is your V minimum. Okay, so this is the total investigation of this system. So for him, so just now the system he rotates. Finally, we conclude him that don't go the V max is 15.5. The V minimum is 2.2. So he can whirl the system with any speed he like between these two values. Okay, if you go less than 2.2, you can't reach the top. Halfway, you're going to fall down. Okay, if it exceeds 15.5, the tension at the bottom going to exceed the maximum tension, which is 500 Newton. It's going to snap at the bottom. Okay, this is the total investigation about this system. Okay. So any questions, guys? This is the most complex one for circular motion. Okay, so Okay, guys. Okay, in exam I tell you, the Vmax and V minimum, V minimum is more famous than Vmax. Very rare. Maybe out of 10 times they ask questions, maybe I can say 9 times they asking for V minimum. Maybe once they ask for Vmax. Okay, so Vmax is low profile. V minimum is very famous. So good to know V minimum. So remember V minimum, you consider the critical point at the top. V maximum, the critical point is at the bottom. The bottom is Vmax because that's where the tension going to become maximum. Okay, tension always turn to become maximum at the bottom. Okay, you can try this at home. You can try this at home. You can do the same thing by, maybe you can try today, but be careful when you do this experiment. Okay, you can stand, you take a bucket of water. Okay, take a bucket of water. Okay, a little water here. You just roll it up and down vertically. Okay, the bucket is going to be upside down. You have to roll it up and down. Okay, with water so that it never spill out from the bucket. Okay, you roll it, feel your tension, feel the pain in your hand. Where do you feel like very, very quite straining your arm when you roll it up and down? Maybe you can try later. Definitely at the top, at the bottom. Definitely at the bottom. At the bottom, your hand act like a string. So you will experience the greatest tension, maximum tension at the bottom, and the bucket is vertically down. So you will experience the greatest tension. Okay, when you roll it the bucket on top, you will be a little relaxed. Your tension will be the minimum. Okay, will be the minimum. We will be investigating this data. Okay, this system. Okay. Okay. So remember, any question, guys, from the no questions? So this entire derivation, just now the A, B, C, the three formulas, the Vmax, where to consider what is the equation, what is the Vmax formula up to here, the Vmax formula. Vmax formula means this Vmax formula. Up to here, you need to write in the notes. You need to write here. Okay. So the space given, expect you to write that the three equation A, B, C. The equation is already in this diagram. Okay. You see at the bottom, T equals to mv squared over r plus mg. So actually, we make the mv squared over r as the subject when we derive just now. So at the bottom is T minus mg. But mg bring the other side is mv squared over r plus mg. Right at the bottom. At the side, T same as mv squared over r. At the top is T mv squared over r minus mg. The equation is in the diagram, ABC. But I want you to write the V minimum. Okay. So V minimum, you consider where? V minimum, consider the top. Consider the top. So when V is minimum, what zero? The tension become zero. Okay. So at the top, so you will get mv squared over r equals to mg. You get the V minimum. V minimum is root of rg. Okay. So write this equation. Okay. And also the Vmax. Vmax, consider the bottom. Consider the bottom. But to find Vmax, they must give extra information about the system. They must tell the maximum tension of the string. If they tell maximum tension of the string, then only we can work out the Vmax. Okay, we can work out the Vmax because Tmax required to find the Vmax. Okay. So I give you 2 minutes. Maybe you take down whatever necessary. Okay. Yeah. So while you are writing the equations into the notes or into the paper, try to understand the flow. Okay, write the equation A, B, C, Vmax, derive this up to the equation enough. Up to the equation enough. Up to here is enough. Okay, for Vmax. Okay, and T V mean is up to root of RG. The calculation only do calculation, just one example I give you. Yes, I give you 2 minutes. Take down the V max and V minimum. Any part you don't understand, you can ask me. Okay, so you have V max, V minimum. V minimum is root of RG. Okay. Yes. Still in time. Okay, so let's we continue. Maybe later you can watch the video also to check these 2 facts and to write on the notes. Okay, let me add. I'm going to ask another one question from this system. Okay, listen carefully. Just now your friend is holding a string with 0.5 meter and and he has a weight of 10 Newton at the edge, and you advise him that the V max is 15.5 and V minimum is 2.2. Okay, now your friend heard this advice, but unfortunately what he did, before he whirl it, he changed the weight from 10 Newton to 20 Newton. He changed the weight from 10 Newton to 20 Newton. But he follow your suggestion. You take V max 15.5, you take V minimum 2.2. If you change the 10 Newton to 20 Newton, any changes going to happen to V max and V minimum? Any change, is it going to happen to V max and V minimum? Do we need to recalculate the V max and V minimum for him? We told him for 10 Newton is 15.5, 2.2, the weight, but he changed it to 20 Newton. If he change to 20 Newton, the V max, V minimum, any change? Praveen, yeah?
Yes, sir.
What do you think? Do you think any change?
I think yes.
There is a change. Which one do you think there will be a change? V max going to change?
Yes, we max.
V max going to change. V max, do you think going to increase or decrease?
Decrease.
You see from this formula?
Is very.
You see from this formula? This is the V max. V max, your weight has been increased, yeah, mg, mg. So most likely the V max is going to increase. The V max is going to change. It will increase. Okay. V minimum, any change? V minimum?
I don't think so.
Riyad, what do you think?
Yes, sir.
Is there any change? V minimum?
I don't think so, sir.
Don't think so. Good. V minimum. So what's your justification? Why you say V minimum won't change?
It's because tension is 0.
But V minimum we consider the top. So V minimum is found to be root of RG, right? So your justification must be based on the formula. So you say V minimum unchanged because V minimum is unaffected by the mass of the load. Mass of the load. The V minimum is only affected by what? The radius and the gravity. The radius and the gravity. The radius of the circular movement and the gravity affects the V minimum. So here we don't have mass. So if we increase the weight from 10 Newton to 20 Newton, the mass is the one rises, but mass don't affect the V minimum. Mass doesn't affect the V minimum. So no change to the V minimum. Okay. So when the weight is increased, V max will change, but V minimum remains the same. So V minimum unaffected by the load has been used in the string tied to the string. That's why V minimum is quite famous. Why is V minimum famous? Because it's not affected by the mass. It's only by the R and G. Okay. Okay, so this kind of question they will ask. Okay. Okay, last question for this system. Okay. What force contribute to the centripetal force in this system? What force contribute to the centripetal force in this system? What type of force contribute to the centripetal force in this system? The combination of tension and the weight. The combination of tension and weight contribute to the centripetal force in this system. Sometimes weight contribute to the centripetal force, sometimes weight oppose the centripetal force. But whatever it is in this system, the tension and weight contribute to the centripetal force. Okay, so this is the hardest example. If you can understand this entire example carefully, the remaining one easy for us to do. Okay. Okay. So if I go to the PowerPoint, so just for a while, I go to the vertical circular motion. Oh, this all we will come back to this. Okay. Okay. So I give you one homework. Try to think about this. What is the homework is? Just on the bucket, the one I told you, like the bucket. Okay. Think about it. Maybe later you can think. You can answer me next class. Okay. Again, you need to advise your friend. Okay. So your friend now is his hand. What is the height? What is the length of his hand? Maybe about around. Okay, I put again. It's about 0.6 meter. The length of his hand. He's holding a bucket. Okay. The mass of the water inside the bucket, let's say, is 1 kilogram. Okay, the mass of the water inside the bucket is 1 kilogram. Okay, 1 kilogram water. Okay, 1 kilogram. Take the gravity as 9.81. Okay, think. You want to whirl it up and down. Okay, you want to whirl it up and down vertically. Get for me, what is the minimum speed? You need to whirl so that the water, when reach the top, the water does not spill off. So what is the V minimum? Minimum speed required so that you whirl it so the water never spill off. So this is the situation I want you to think, and I want some idea for tomorrow. Okay, my advice, how do you investigate is same like the earlier investigation we done with the string. Okay, string with the mass, but here string with water. So what you do, you focus the water. For that water, you write what are the forces acting to the water. What equals to Fc for the water? Write that first. At the bottom, at the top, what equals to Fc? What are the forces acting on the water? Okay, and from that Fc, V minimum means check which point do you consider. Which point is the critical point for the water never spill off? Definitely the top point, right? The top point. Then check when V is minimum, what should become 0, the lowest value. Think about it. Okay. Okay, so tomorrow I'm expecting you the answer. V minimum, how much for this person who has an arm of length of 0.6 meter, carries in the bucket, got 1 kilogram of water. What is the minimum speed you need to whirl so that at least the water does not spill down at the top? Okay, so this is your homework. Okay, think about it. Any questions, guys, before we stop? No questions, huh? Okay, so just before we stop, some of you asked me which paper to do for next week Wednesday discussion. Go to the trial paper. Go to the trial paper. Yeah, this is your trial paper column, AS trial. Go to the bottom, paper 35, right? Don't do this. This is your practical. You go to the next paper. The AS Gen paper 2 Gen 20. This one, give a try this paper, check the mark scheme. Then if you have time, go ahead, do the next paper. These two papers. AS trial paper 1, August 2020. One paper 2, one paper 1. Okay, this try before Wednesday, we'll be discussing this. Okay, check the mark scheme, check your answer, get ready with your questions, which you don't understand. Okay, guys. Okay, so I stop here. Thanks. See you back tomorrow. Oh, you know why I joined or you know how to join?